In this session, what I'm going to do is I'm going to teach you about factors. So all the questions which are related to factors is what we are going to discuss in this session. So in the previous video, we have already seen prime factorization, right? Okay, so you already know what is prime factorization, and after that we have seen the application of prime factorization in finding LCM, HCF, etc. Now here, once you prime factorize the number, I teach you how to find factors of a number. So this is very basic and very simple question, but from this I'm going to discuss about many other possible questions. Okay, so finding factors, I hope all of you might be knowing it. It's very simple actually, and you may not get any direct question of finding factors or number of factors, etc., but you may get some other question, and that's what we are going to see in this session. Okay, so what do you mean by prime factorization? That we have already seen that any composite number like 10 is a composite number, you can write as prime number, 2 into 5. So any composite number you can represent as prime numbers. So this is what prime factorization. Any composite number can be factorized into prime numbers, and this factorization is actually unique. So this is the only one way in which you can prime factorize. You cannot write 10 in any other way. Okay, this is the only one way in which you can write, and that's what fundamental theorem of arithmetic. If you see your 10th standard NCERT, the first chapter is about this, fundamental theorem of arithmetic. What is that? Any composite number, if you take, you can prime factorize, and that prime factorization is unique. Only one way you can prime factorize any number. So if I ask you 30, you will tell me 2 into 3 into 5. And this is only one way in which you can write 30 as prime numbers. There is no other possible way. So that's why I told you this prime factorization is unique. Now, based on this prime factorization, let's take 30. Okay, 2 into 3 into 5. I can find number of factors of 30. Okay, so what you have done here, 2 raised to 1, 3 raised to 1, 5 raised to 1, right? This is what prime factorization of 30. Now, the number of factors of 30 will be, see, the powers are 1, 1, 1, right? So the number of factors will be 2 into 2 into 2. I tell you why and how, etc. But I'm just writing. This is 2 cube, which is nothing but 8. So 8 factors are there for 30. Okay. So what are the 8 factors? 30 and 1. Obviously, these two are factors. Then 15 and 2. Okay. Then 3 is a factor, so 10. Then 5 is a factor, so obviously 6. So you got 8 factors. Okay, so these are the 8 factors. So 30 have 8 factors, and these are the 8 factors. Now how you got 8? From this only you got 8. How? I'm going to generalize it. Let's suppose you have a number n. Here it was 30. So n you can prime factorize, and you can write it as a raised to m, b raised to n. If you can write like this, that means a and b are prime factors. Here I am talking about 2 prime factors, like 10 means 2 into 5, so only 2 prime factors. When it comes to 30, 2 into 3 into 5, so this n become a, b, c. Okay, so a raised to m, b raised to n. Number of factors of n is equal to, see here if you observe power is m, so m plus 1, here power is n, n plus 1. So number of factor depends on the power. Once you prime factorize, then this is not important. Then power is important. So you'll write it as m plus 1 into n plus 1. So 10, if you take, how will you prime factorize? 2 into 5. So this is actually 2 raised to 1 and 5 raised to 1. So number of factors will be this 1, so 1 plus 1 into this 1, 1 plus 1. So 2 into 2, which is equal to 4. Now what are the factors? 10 is a factor, 1 is a factor, 5 is a factor, 2 is a factor, and these are the 4 factors. I hope this is clear for all of you. So if you take 12, how will you prime factorize? 2 square into 3. So how many factors? This is 2. So you can write as 2 plus 1, which is 3. Here it is 1. So you'll write as 1 plus 1, which is 2. So 6 factors will be there for 12. What are the factors? 1 and 12. Obviously they are factors. Then 2, 6, they are factors. 3, 4, they are factors. So these are the 6 factors. So I hope this is clear. Now, what is fundamental theorem of arithmetic? You don't want to know the theorem. That is nothing but this prime factorization. 12 you can prime factorize, and you can prime factorize only in one way. There is a unique way in which you can prime factorize, or you can write it in only one way. Okay, then number of factors is this. So you understood 6 number of factors are there, and these are the 6 factors. Now imagine that you're an examiner. What are the questions you can make? Okay, what are the questions you can make just by looking into these factors? Now I know these are the factors of 12. Now you're an examiner, you are sitting to make questions. So think what are the possible questions you can make with the 6 factors. You already know there are 6 factors, and you know the 6 factors. What are the 6 factors which you can make? Now with 12 it is going to be easy, but if I take it to 1200, 1300, 1400, etc., or beyond that, the question will be difficult. If I give you a number like 1731, I can make a difficult question, but let's see what are the questions you can make from 12. Then we can shift to the other numbers. Okay, so if you're an examiner, the first question you can make is actually, these are the factors, you add the factors, that is 1 plus 2 plus 3 plus 4 plus 6 plus 12. So I gave you a number 12. What is the sum of factors? Then what is your answer? You need to add all this. Since it is 12, you can manually find and you can get the answer faster. But what if I gave you something like 1832? This is going to be a difficult question. But hold on, I'll give you a method for that. Okay? So if I can ask you sum of factors, what else I can ask you? I can obviously ask you product of factors. So here comes the second question. 1 into 2 into 3 into 4 into 6 into 12. That's the second question which I can make. So first is actually number of factors. Second question I can ask you sum of factors. Third question I asked you product of factors, right? So if 12 is the number, this is going to be very easy. But instead of 12, if it is 1837 or 1838, etc., then it is going to be a difficult question. So you need a method, right? We'll discuss the method. Now what else you can ask? Just by looking into these 6 factors, think of other possible question. See, if you look here, this 1 and 3 are odd numbers. So out of 6 factors, how many odd factors are there, right? So the fourth question which I can make is, how many odd factors are there? So if I can ask you number of factors, that is 6, I can ask you how many odd factors are there, right? So we will give you a method for that also. So if I can ask you odd factors, I can ask you how many even factors are there. So obviously that is going to be easy. If you know the method for finding odd factors, you know the total number of factors, which is 6, minus odd factors, you get even factors. Or if you know the number of even factors, subtract that from the total number of factors, you get odd factors. Okay, so you just need to know the method of finding either odd factors or even factors. You can get the others easily. So the other question can be, how many even factors? So from nowhere I made 5 questions. So otherwise, after, see, what all things we have discussed under prime factorization, from this we have made 5 questions. So first is number of factors. You know that is 6 here. You know the method also, m plus 1 into n plus 1. Okay, then sum of factors, product of factors, odd factors, even factors. Now is there any other possible question from this? No, these are the possible questions. Now from the concept of factors, we can have some other questions also. We will look into that after solving all these 5 questions. The solution for the first question, number of factors, I have already given you. M plus 1 into n plus 1. So if a number n can be written as a raised to m, b raised to n, number of factors is m plus 1 into n plus 1. If you have one more prime factor, let's suppose c raised to p, then you have p plus 1. That's it. Like in case of 30, you have 2 into 3 into 5. So in all these cases power is 1. So 2 into 2 into 2. So you got 8. I hope this is clear for you. So if I give you this number 1771, the way in which you can prime factorize, you can do it later. It's actually 7 into 11 into 23. So number of factors will be, this is 1, this is 1, this is 1. So 2 into 2 into 2, which is equal to 8. For 1771, you have 8 factors. Just by using the method of prime factorization, you are getting the answer. That's the point which I need to tell you. So if you take one more, like 10626, you can prime factorize it as 2 into 3 into 7 into 11 into 23. Actually 10626 is, when you are multiplying this number with 6, you are getting this. That's why 7, 11, 23 and 7, 11, 23 is same. Here 6 you prime factorized. So in this case, the number of factors will be, this is 2, this is 2, here also 2, here also 2, here also 2. So 2 raised to 5, That means 32. Number of factors will be 32. So I hope this concept is clear, number of factors. Now let's look at the next type, that is sum of factors. Okay, I give you the formula directly, but it is actually very easy. It's like you have number a raised to m, b raised to n. The formula may look difficult, but application will be very easy. I give you examples also, and we will solve examples, then you will realize it. Okay, so the sum of factors of this number is, you write here a minus 1 divided by a minus 1, okay, into b minus 1 divided by b minus 1. Now you may think that a minus 1 and a minus 1 is getting cancelled out, b minus 1 and b minus 1 is getting cancelled out, right? So it will be getting cancelled out, so this is not the formula. Just to make it simpler, I have written this first, but I need to add some more. Now see, m plus 1 into n plus 1 is the number of factors, right? So we need to use this. So this m plus 1 we will write here, this n plus 1 we will write here. So I hope you will not forget it. A by a minus 1, b minus 1, you write like that, a minus 1 divided by a minus 1, b minus 1 divided by b minus 1. Then number of factors, you know the formula m plus 1 and n plus 1, you write like that. This is the answer for sum of factors. So in case of 10, let's take 10, very simple number, 2 into 5, right? 2 into 5. So 2 raised to 1 and 5 raised to 1. So how will you find? A is actually 2, B is actually 5. So you write it as 2 minus 1 divided by 2 minus 1 and 5 minus 1 divided by 5 minus 1. Now what about the power? That is 1 plus 1 here, that is 2, here also 2. So this become 2 minus 1, 1. This is 4, right? 5 minus 1 is 4. So 2 square minus 1. 2 square is 4 minus 1, 3. So this is 3. 5 square minus 1, that is 25 minus 1, 24 divided by 4, 6. So sum is 18. Now why you are getting 18? Because sum of factors of 10. What are the factors of 10? 2. And what are the factors of 10? 2, 5, 10, 1. So 10 and 1 are factors, 2 and 5 are factors. So if you add, you get 18. That's what sum of factors. I hope this is clear for all of you. Now similarly, next question is product of factors, right? So product of factors. See, if you can write n as a raised to m, b raised to n. This is your n, right? So product of factors will be, now the formula looks very difficult, but I'll try to simplify it so that you will not forget it. Okay, the formula is actually this, a raised to m, b raised to n, whole raised to m plus 1 into n plus 1 divided by 2. Let's simplify. This is actually the formula. Let's simplify, then it will become very simple for you. What is this a raised to m, b raised to n? We know this is n. So you just write the number. Then what is this power? What is this m plus 1 and n plus 1? That is nothing but number of factors. We have just seen that, right? So n raised to number of factors by 2. That's the product of factors. Very simple. The number which is given raised to number of factors by 2. So 10. If I ask you product of factors of 10, what is your answer? You will first write the number. Then you will write the number of factors of 10, right? We know that is 4. So that is 4 divided by 2. So 10 raised to 2 means 100. So product of factors is 100. Now why you are getting it? Let's see the factors of 10. 2, 5, 10, 1. Multiply everything. 2 into 5, 10. 10 into 10, 100. 100 into 1, 100 itself. So you're getting 100. I hope this is clear for all of you. So if you need to find the product of factors of a number which is given raised to number of factors, you know, by using the formula m plus 1 into n plus 1 divided by 2. Clear, right? Now next is, you need to see number of odd factors and number of even factors of a number, right? So let's take 30. You need to find the number of odd factors and number of even factors. So we already know the factors of 30. That is 31, 15, 2, 10, 3, 6, 5. Okay. So let's see number of odd factors and number of even factors. I give you the method. So first you need to prime factorize 30. 30 is equal to 2 into 3 into 5. Now to find odd factors, first I am going to find odd factors, number of odd factors. Just remove this part. Just remove the 2. Okay. Just remove 2 and powers of 2 don't consider. Take 3 into 5 part only. So what is the power of 3? 1. 5. It is also 1. then apply the formula of number of factors. What you did, you just removed this 2, nothing else, and then apply the formula of number of factors, that is nothing but 2 into 2, which is equal to 4. What is this 4? That is the number of odd factors. Let's see how many odd factors are there. 1 is there, 3 is there, 5 is there, 15 is there. So 4 odd factors are there. So how you find it? You remove 2, apply the number of factors formula 4, rest of the numbers 3 and 5. Now, how can you find even factors? Then it is actually very easy, right? If you know the total number of factors, which is 8 minus 4, you get even number of factors. Or you get number of even factors. But the other way in which you can find is 30 you write prime factorized as 2 into 3 into 5. Now, you need to apply the formula of number of factors. But this 2 is what making the change in both cases. So in case of number of odd factors, you remove 2. In case of number of even factors, when you're applying the formula, all these powers are 1, 1, 1. Here, when you apply the formula, instead of m plus 1, don't put that plus 1. Just put m itself. That means drop the power just like that. Here it becomes 1. But in these two cases, you do it normally. That becomes n plus 1, 2 into 2. So you get 4. I hope this is clear. Only this 2 is making the difference. This 2 is actually deciding even factor or odd factor. So here you won't take this, see this 2 raised to 1 means it's actually 2 raised to 0 and 2 raised to 1. So this you don't take. That's what you are avoiding, right? Because anyway 2 raised to 1, if it is there, it will give you only even factor. 2 raised to 0 may give you odd factor because that is 1. Okay, so that's why you are avoiding that, and that's why you are not adding 1. Here, in case of odd factor, you are completely removing it. Let's take one more example. Let's take a number 240. Okay, 240. How will you prime factorize it? You will prime factorize it as 2 raised to 4 into 3 into 5. See, it's actually 16 into 15. So 16 is 2 raised to 4, 15 is 3 into 5. Now, you need to find all the 5 answers. Number of factors, sum of factors, product of factors, number of odd factors, number of even factors. Then the discussion is complete, right? So, what is the number of factors here? Let's look at the power. So here it is 4. So 4 plus 1, 1 plus 1 and 1 plus 1. So that becomes 5 into 2 into 2, which is equal to 20. So how many factors are there for 240? 20 factors. So number of factors, you got the answer as 20. I hope this is clear, very simple. Now what about sum of factors? You need to be little careful here. Sum of factors. So I told you, you should not forget it. A minus 1, B minus 1, A minus 1 by A minus 1, B minus 1 by B minus 1, C minus 1 by C minus 1. So you'll not forget it. All these are multiplication. And this is M plus 1, N plus 1, if you want P plus 1. Okay. Then what is A, B, C here? 2, 3 and 5, right? So let me write like that. 2 minus 1 by 2 minus 1, 3 minus 1 by 3 minus 1, 5 minus 1 by 5 minus 1. Okay. Now let's write the power also. M plus 1 means 4 plus 1, that is 5. So here it becomes 5, here it becomes 2, here it becomes 2. Okay. Now let me complete it. 2 raised to 5 means 32. 32 minus 1 divided by 2 minus 1, which is 1. 3 square means 9. 9 minus 1, 8 divided by 3 minus 1 is 2. 5 square is 25. 25 minus 1, 24. Divided by 4 minus 1 is, divided by 5 minus 1 is 4. So 24 divided by 4. So this is getting cancelled. This is getting cancelled. And this is 31. Right? So 31 into 4 into 6. So you get 31 into 24, which is equal to 744, right? Now after this what? We need to see product of factors. This is going to be very easy, right? Product is the number which is given 240 raised to number of factors divided by 2. So number raised to half the number of factors, right? So number of factors you already know 20. So half is 10. So this is the answer for product of factors. Now how many odd factors? You write the number again. 240 is equal to 2 raised to 4 into 3 into 5. For odd factors, we cut this, right? Then we apply the formula of number of factors. So it becomes 2 into 2. So 4. So 4 odd factors means how many even factors? 16. We know that. But let's apply the formula again. 240 is equal to 2 raised to 4 into 3 into 5. Now will you apply the formula? This power of 2 you will drop like that. You don't apply the formula just like that. Okay. Avoid that 1. So 4 will become 4. This 1 and 5 raised to 1 will become 2 and 2, right? 2 into 2. So you get 16. So that's how you got number of factors as 20. In that 20 you can see 4 odd factors and 16 even factors. And sum of factors as 744 and product of factors is 240 raised to 10. And these are the possible questions that can come from factors. I hope all of you understood this completely. There is no need to have any doubt from factors now. Now, some typical questions which can be asked based on factors is actually, see, let's take one example. From that again you can make different possible questions. How many numbers less than 100 have exactly 2 factors? So what do you mean by exactly 2 factors? I'm talking about which number? Prime number. So prime numbers have exactly 2 factors, 1 and that number itself. So what does this question means? How many prime numbers are there less than 100? You can find it manually. I give you the answer 25. But they can obviously ask you 1000 also. So if the question is how many numbers less than 1000 have exactly 2 factors, don't try to find the answer at that time. If you know it already, just mark it. Otherwise, don't try to count the number of prime numbers less than 1000. I hope you understood the logic, right? Now, they can also ask you how many numbers less than 100 have exactly 3 factors. Exactly 3 factors. So basically what do you mean by 3 factors? It's actually m plus 1 into n plus 1 is number of factors which is equal to 3. Now we know this m plus 1 and n plus 1 has to be an integral value, right? So when you multiply 2 numbers you are getting 3. Is there any integral values possible for this? See, minus 3 and minus 1 will give you, or 3 and 1 will give you. Okay, but if it is, this is anyway not applicable. What if it is 3 and 1? Is this possible? If it is 3 means, see, imagine you have this number a raised to m, b raised to n. If 3 means m is 2, right? So 1 is 2, but what about this one? That is actually 0. Then only this become 1 because n plus 1, right? And then this is actually 1. So there is no prime number involved here. So what you can conclude is there is only one prime number involved. And the power of that prime number is actually 2. This is 2. And that's why you are getting 3. So this is actually not there. So what you understood? There is only one prime number involved here, or there is only one number involved in the prime factorization. Obviously that's a prime number and the power is 2. What does this mean? The number is actually a prime square number. So the numbers which is having 3 factors, the numbers which is having exactly 3 factors means I'm talking about prime square numbers. So if I ask you how many numbers less than 100 have exactly 3 factors, you need to find the prime square numbers less than 100. Let's take one prime square number. Let's take 2 square. 2 is a prime number. 2 square is equal to 4. Let's see the factors. 1, 2, 4. 1 and 4 is a factor. 2 into 2 is a factor, but I'll take only 1, 2. That's why 3 factor. If you take 9, 1, 9 and 3. If you take 25, 1, 25 and 5. All these have exactly 3 factors. So I need to find number of numbers less than 100 have exactly 3 factor means I need to find the prime square numbers less than 100. So 2 square, 3 square, 5 square, 7 square. Then 8 is not a prime number, 9 is not a prime number, 10 means 100 is over. So how many numbers have exactly 3 factors less than 100? 4 is your answer. 4 is your answer, right? I hope this is clear for all of you. What if my question is how many numbers less than 1000 have exactly 3 factors? Less than 1000, then what is your answer? This is a CAT question. So the question is how many numbers less than 1000 have exactly 3 factors. So what do you need to do? You need to find the prime square numbers less than 1000. And this you can do it faster because see 30 square you know 900. 32 square you know 1024. So anyway, numbers less than 32 square is what I am looking for. What about 31 square? That is 961. So 31 is actually a prime number. So I am looking for prime numbers up to 31. I hope this is clear. Because 32 anyway, not possible. 32 square is more than... See, even if you don't know the squares, I hope everyone know 30 square is 900. Then 31 square will be less than 1000, everybody know. If you don't know perfectly 1061, that's not required. It is less than 1000. 32 square Even if you don't know whether it is less than or greater than 1000, you know 32 is not a prime number, it's a composite number. 33 is also a composite number. 34 is also composite, 35 is also composite, 36 is also composite. By this time anyway 1000 will be crossed. So you don't want to know perfectly the square or whether it is less than 1000 or not. You just need to know 30 square is 900. 31 square is less than 1000. That is common sense. So what you need to look for is actually number of numbers, number of prime numbers less than 31. So how many are there? 2 is there, 3 is there, 5 is there, 7 is there, 11 is there, 13 is there, 17 is there, 19 is there, 23 is there, 29 is there, 31 is there. So this is your answer. Just count and write the answer. So number of numbers having exactly 3 factors less than 1000, this is your answer. I hope the logic is clear for you. Now, I give you a very special question. How many numbers less than 100 have odd number of factors? See, earlier what we have seen is number of odd factors. Now I am talking about odd number of factors. Both are different. Okay. So number of odd factors is what we have discussed. That means within factors, let's take 12, 1, 4, 3, 2, 6. Within these factors, 1, 3 are odd factors. So number of odd factors means 2. Here I am talking about odd number of factors. Just now I have given you exactly 3 factors. That's actually odd number of factor. So 5 factor means odd number of factors. So what are the numbers? How you are getting this odd number is basically because if you find the factors of a square number, let's take 16. Let's find the factors of 16. What will happen? 1, 16, 2, 8, then 4 into 4. But you won't take this 2 4s, you'll take only 1 4. That's why you're actually getting odd number. Otherwise the factors coming in couples, pair, right? But when it comes to square, you'll take only 1. So the moment you see odd number of factor, you are looking for square numbers. Square numbers will have odd number of factors. So if I ask you how many numbers less than 100, keep in mind less than 100, have odd number of factors. What is the answer? You need to look for how many square numbers are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Less than 100 means I can't take 10. So number of numbers have odd number of factors, 9 numbers. What are the numbers? 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, etc. These are the numbers. So square numbers will have odd number of factors. So I hope this is clear. Number of odd factors and odd number of factors has to be very clear for all of you. You should not make any confusion or any doubt. And you know the method of finding both. So odd number of factor means it's a square number. Why odd number? Because the factors will obviously occur in pairs, but in case of square number, one among the pair, you need to take only one number because it's actually a repetition. 4 into 4, 5 into 5, 11 into 11, like that. That will come only in case of squares. So what all things we have discussed? If a number can be represented as a raised to m, b raised to n, first we started off with number of factors. I hope all of you understood this, right? M plus 1 into n plus 1. Then if you can find the number of factors, you can obviously find sum of factors. And what is the formula? A minus 1, A minus 1, B minus 1, B minus 1. Then number of factors formula, M plus 1, N plus 1. Everything depends on number of factors formula. Then we have seen product, right? If sum can be asked, you can find the product also. It's very simple. The given number n raised to number of factors by 2. Number of factors anyway, you know, n plus 1 and n plus 1. For that also you need to prime factorize anyway. Then we have seen number of odd factors. Don't have any confusion between odd number of factors and number of odd factors. When you are finding the factors of 12, you are having how many factors? You are having 6 factors. So this is actually even number. Within this, if you see 12, 1, 3, 4, 2, 6. Within this, 1 and 3 are odd numbers. That's what I am talking about, this number of odd factors of a number. So total number of factors, if you see, that's even number, but number of odd factors 2 in that. What if I ask you odd number of factors? Numbers having odd number of factors, that means I am talking about square numbers. This has to be very clear for all of you. Then we have discussed about number of even factors. You know the method of finding number of odd factors and even factors. Now I don't want to ask you even number of factors because every composite, the numbers which are not square number will have even number of factors. That is very easy, obvious. Okay, then we have discussed about exactly 3 factors. This is nothing but exactly 3 factors, prime, square numbers, right? Then we have discussed about exactly 2 factors, which is obvious, prime numbers. And that's what we have done in this session. So I hope all of you understood this much. Any question from this can be solved faster.